Besides representing complex numbers by vectors, they can also be represented by points. In example 12, we are supposed to mark down the points z and z conjugate representing the complex numbers z and z conjugate respectively. In part A, z equals to 2 plus 3i. So because of the 2, we move 2 units in the positive real axis direction, and because of the plus 3i, we move 3 units in the positive imaginary direction, and this point represents the complex number z. Z conjugate in this case will be 2 minus 3i. So in this case, because the real part is still 2, we go 2 units in the positive real axis again, and because the imaginary part is negative 3i now, it means that from here we have to move down 3 units in the negative imaginary direction, imaginary axis direction. So this point will represent the z conjugate. Now for example 12b, before we draw the Argand diagram, we must always draw the axis and label them correctly. So I'll label this the imaginary axis, whereas the horizontal axis have been labeled the real axis. Now take note that in this question we have a printing error in the question, so please insert a -1 here. Z equals to -1 minus 2i now. Because of the -1, I will go 1 unit to the left from origin, and because of the -2i here, I know I have to go downwards by 2 units. So this point will represent z. In this case, since z is -1 minus 2i, z conjugate will be -1 plus 2i. Now z conjugate will be very much like z. For the real component is exactly the same. So again we go to the left side by 1 unit. Now because in this case the imaginary part is a plus 2i, I know that I have to move upward by 2 units. So this point will represent the complex number z conjugate. As you observe the Argand diagram, notice that z and z conjugates are mirror images of each other in the real axis, with the real axis as the mirror line. Thank you for watching this video.